Hello everybody, a very warm welcome to all the viewers of Wisdom Jobs. In this video, I am going to explain some concepts of electric field intensity and force due to N charges in an electric field. Okay, so before going to this particular topic, I am requesting you all to please do subscribe to our channel wisdomjobs.com and please like and share our videos because they will be useful for your friends and also in other competitive examinations. So with this note, let me start the topic. Today's topic I'll be dealing with electric field intensity. Electric field intensity. Yeah. Now I think in the last video we might have discussed about the concept of electric we might have discussed about the force due to Coulomb's charge. Okay, now in this class I'll be discussing about force due to N charges and electric field intensity. Now let me consider an electric field which is containing, let me say, n number of charges like this. So q1 at p1, q2 at p2, like that, n number of charges each located at their respective positions, and let the nth charge be qn. Okay, so due to this n charges, I wanted to determine the total force acting upon a point, let me say p. Okay, so I am interested in evaluating the electric force at the point P. Now, since there are n charges, there would be n number of forces. Okay, so starting with force due to Q1 on P, okay, force due to Q2 on P, force due to Q3 on P, like that. So let me say the point P has a charge of Q. So what is Q? Q is the charge located at point P. And what are Q1, Q2 and all? They are n number of charges present in the electric field nearer to the point P. So let us evaluate the total force acting upon the point P. Okay. Now due to Q1, what is if due to Q1? F1 would be Q into Q1 upon 4 pi epsilon naught d square. I mean in fact it is d1 square into a1 cap. Okay, and what would be F2? F2 would be Q into Q2 upon 4 pi epsilon naught d2 square into A2. So what is d2 here? Obviously it is a distance between the point P and the location of the second charge. Like that, if I go on adding, go on calculating the nth force, so what would be Fn? Fn would be Q2 upon 4 pi epsilon naught d square into a n cap. So what is this a n cap? It is the unit vector along the line joining the point P with the nth charge. Okay. Now, so we have got n components for forces, right? So what would be the total force then? Total force is F suffix T. That would be F1 plus F2 plus Fn, right? Now let us replace all these expressions in Ft expression. So what would be F1? Q1 by 4 pi epsilon naught d square, I mean d1 square into a1 cap plus Q2 upon 4 pi epsilon naught d2 square into a2 cap, right? So similarly, if you observe the remaining expressions, Q into Q3 whole divided by 4 pi epsilon naught d3 square into a2, a3 cap, so on and so forth, up to Qn upon 4 pi epsilon naught dn square into an cap. Okay. Now let us do some common terms. Let us take away some common terms. So if I take away some common terms, Q upon 4 pi epsilon naught into Q1 by d1 square into a1 cap plus Q2 by d2 square into a2 cap plus so on and so forth up to Qn upon dn square into an cap, right? So this is the final expression for the total force acting on a charge located at point P due to n number of charges Q1, Q2 up to Qn. Okay. Now, in the next video, let us work out some problems based on this. But as an extension to this particular topic, I am going to deal with the next topic, which is electric field intensity. Right. So now let me explain you what is electric field intensity. Now, force is F. Now let me say there is the total force acting on a particular charge is Q. Okay. So on a particular charge in a particular electric field, let me say the total force acting on a charge Q is, let me say, F. Okay. And of course, F may be due to a number of charges, or one charge or two charge, depending on the electric field containing the number of charges. Okay. And obviously, the electric field intensity at this point P is force per unit charge. Okay. It is simply force per unit charge. So, electric field intensity at a point P would be simply the total force acting on that point divided by the charge at that location. Okay. Now, let us go for some simplification here. So, for example, the test charge at P, let me say it as Q. Okay. So, what is the total force acting on Q now? Due to another charge Q1. So, due to another charge Q1 upon 4 pi epsilon naught d square into a cap, this divided by Q, right? So, Q and Q gets cancelled. So, E, you have got it as E bar, of course, strictly speaking, it is a vector quantity. So, we need to put a bar. So, E bar is equals to Q1 upon 4 pi epsilon naught d square into a cap. Okay. So, this is the expression for electric field intensity due to a point charge. Okay. So, now let me explain you once again, so that you don't have any confusion. So, always electric field intensity is defined as the force upon unit charge. Now, if you observe in the final expression for electric field intensity, at whatever point you are interested in determining the electric field, that charge will not be there in the numerator expression. So, in the numerator expression, opposite charge, that means other charge would be coming into the numerator, that divided by 4 pi epsilon naught d square into a cap. This would be the final expression for electric field intensity. Okay. Now, in a similar manner, let us extend this argument or this definition of electric field intensity due to n charges. Now, let me say an electric field is containing n number of charges. Now, let me name them as Q1, Q2, like that, Qn. Okay. Now, due to this n number of charges, let me say the total electric field intensity at a point charge at a point P would be, let me say, E. Okay. So, what is E here? E is the total electric field intensity at point P due to n number of charges Q1, Q2, Q3, so on and so forth up to Qn. Right. Now, let me say the test charge at this point is some Q. Okay. Let the test point at P is Q. So, what is the electric field intensity now? Total electric field intensity is 1 by the test charge at the test charge at P into the total force. So, what is the total force? We have Q into Q1 upon 4 pi epsilon naught d1 square into a1 cap. So, this, I think this definition just now I have taught you, right. So, plus Q2 upon, so what is this first term? The first term is the force due to Q1 on Q. Second term, which I am writing now, is the expression for the expression for the force due to second charge on Q. Okay. Like that, if I go for nth charge, plus Qn upon 4 pi epsilon naught dn square into an cap. Okay. Now, just cancel away Q throughout. So, cancel away Q. So, you will be getting total electric field intensity now is simply Et is equals to Q 1 by 4 pi epsilon naught is a common term. So, I will throw it out, 1 by 4 pi epsilon naught into, you have got Q1 upon, so it is d1 square into a1 cap plus Q2 upon d2 square into a2 cap plus so on and so forth up to last term would be Qn upon, it is dn square into an cap. So, this is how we can determine the electric field intensity due to n charges. And if you observe this expression for ET, the total electric field intensity, never you have the same charge which is there at P in the main expression. So because why it will not be there, it will get cancelled away due to the denominator. Okay, so since Q should be taken in the denominator, it gets cancelled away. So the final expression for n number of charges electric field intensity is this one, the final expression. Okay, so in the next class we are going to work out some more problems based on this particular topic, and we will I think you might enjoy more when we are doing the numericals. Okay, so I think this topic you might have already comprehended comprehensively, and I think if you have any queries or doubts, please do express them in the comment box which is provided at the bottom of the video, so that whenever we find time we will try to answer your queries. Thank you for watching this video.